So here we go. On page 25, this is an application question. Here they gave you the equation. In an Australian city, the time of sunrise can be found using the trig function, blah, 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 where t is the number of hours past midnight and d is the number of days into the year. In Australia, I would assume it's going to be the opposite of us. The longer days are in January. The shorter days are in July. I know enough geography to know that. I'm asking you, if they give you the equation, are you comfortable either finding an x value or a y value with your graphing calculator? If not, I'll go through this if you want me to, but here is where we will ask. Would you like me to try this question, or are you pretty comfortable typing stuff in? Try it. Get your calculators out. Make sure you're in radians. Hey, I am. Clear whatever's sitting there. You know what? Let's go character by character. Now, those of you who are okay can type ahead, but let's go character by character. I would type 4.5. When I hit sign, Dominique, my calculator automatically opens a bracket. Where will I close that bracket off? Right in front of the plus sign. I will remember to do that. Now I'll continue to type. I see a pi. Then I see another bracket, x minus 3, close bracket. And underneath the pi, what do you see, Itzel? Divided by 180. You probably could have gone pi divided by 180 times x minus 3. I know some calculators are sloppy with fractions, so I've learned to be paranoid. Shannon, I do all of my times zing and all of my dividing. Why would this be wrong? Typing a plus sign right now. Said I'm going to close the bracket off in front of the plus sign. So close off the bracket, plus 5.1. Now there's the equation typed in. Let's think about a good view window. Now, what's sitting where the x normally is? What letter, Shannon? What's D measuring according to this question? So, from 0 to what? I think 365. Scale, I usually, if I'm doing a year, go up by 30s to get roughly a month. Okay. Sabrina, what's the vertical displacement of this graph? Yep. What's the amplitude? What's the highest this graph's going to get? That and that. 9.6. What's a nice round number a little bit bigger than 9.6? I would go 10 or 12. You know, I'm going to go 12 because I'm always worried that this crummy screen will chop something off along the top that it didn't mean to because it's a lousy resolution. So I'll go to 12. I like to see the ground. 12 scale. I don't know if I twos. Let's see if I hit graph. Sunrise seems to be earliest in October, latest in January, February, March, April, somewhere around there. I'm not quite sure how the seasons work, or this might not be an accurate graph. I don't know. What do they want me to find in A? It says, what time to the nearest minute is sunrise on the first day of the year? Okay, let me copy this first of all. And let me copy this next of all. I type that. And let me copy this third of all. So I'll put all of this in there for you, Shannon. Isn't that nice? Except I'm going to move this guy up to there. Move this guy up to there. You're not going to let me put them side by side? Come on, you're going to let me put them side by side. Because Good enough. I'm not going to be fussy. First day of the year. Oh, day is X values. You know what? I think what they want me to do is they want me to go find the Y when D equals 1. If they give me an X value, that's when I hit trace. 1. 4.943. 4.943 hours. Now they want to the nearest minute, so it's going to be 4 a.m. and how many minutes? I'm going to take that 0.943 and I'll multiply it by 60 to go from hours to minutes. 4:57 a.m. Okay. B asks, on which day is the latest time of sunrise? Now this involves using a maximum or a minimum. I would not ask you that. So I'm going to go... C is fair game, though. C says, determine the number of days in the year that the sun rises after 7 a.m. 7 a.m. I think that's a Y value. I think what I'm going to do is send a line across the screen 7 high. I think what I'm going to do is go Y2 equals 7. Let's see how close I was. Hey, I was pretty accurate with my rough sketch there. That's not bad. Do you know how many days the sun rises after 7 a.m.? This many days right here. How can I find that out? Find the first intersection. That's when it starts after 7 a.m. Find the second intersection. That's when it ends after 7 a.m. And subtract to find out how many days are in between. Is that okay, Dominique? Good, then do it. 130 days. I'd probably also accept 129 days because it all depends on how you round off. The fact that I got 27.9, I said, oh boy, is that 28 days or is that 27 days? Would I round up or would I round? I went to 28 days. Is that okay, Amanda? It's going to be some test on the multiple, some question on the multiple choice where I give you the equation and say do something with it. On the written, that's when I'm going to give you the word problem and actually say find the equation. Is that okay? Similar, I think, to number 25. Ferris wheel. I think this question actually asks you to graph it. Do they? I'm not going to ask you to graph it. Did I test graphing on the last test? Yep. Would I sketch it? And you'll notice I say sketch because I'm going to do a lousy graph. I'm not going to care about scale. I'm not going to divide by 4 to find what portions of the period. I'm not going to pick a horizontal scale. I'm not going to find a common denominator. I'm just going to do a sketch. What am I interested in? Highest, lowest, which hopefully will tell me middle. Okay. Can you, from this word problem, tell me either the highest or the lowest or the middle or all three? Or there's one that seems pretty obvious to me. That's the lowest. You know how I know? Because it says is at the lowest point. What's the middle? Because isn't the radius mean the middle's there and it goes 21 down and 21 up, right? Radius is always your amplitude. What's the highest? I 46, because That's your radius, that's your amplitude. That's your radius, that's your amplitude. I got highest, lowest, and middle. Which of these three numbers appears in my equation? That guy? No. That guy or that guy? The middle. My vertical displacement is going to be 25. I guess they want me to use a capital H for height. Okay, I'll humor them. I'll give myself a bit more room, though. Oh, what did you say the amplitude was? This distance here and here? 21, which is going to be the radius. They said to use cos. Okay. Says the loading platform is 4 meters above the ground. I think we can assume that people get on right there. Which trig function starts at the bottom? Yeah, I think I would go with a negative cos, and that would give me no phase shift. What's the period of this graph? I couldn't hear you. No. Again, you're going one step further. What's the period of this graph? It's not 2 pi over 35. That's b. What's the period of this graph? Keep it simple. How long does it take to go around once? No. How long does it take to go around once? Sorry? Doesn't. It says to go from here to the highest takes 35 seconds. How long to go back to where it started from and go around once? And that's the period, Dominique. You were giving me B already, and you'd done the sloppy period, but period is 70. Dominique, what's B, the number that's going to go here, which is not the period, it contains the period? Yes! There's a perfectly valid equation. Now, this one seems to suggest that it wants me to use positive cos, because I didn't put a negative there. Oh. Positive cos would start right there. What x value is that if this is 0 and this is 70 seconds? What x value is that? T minus 35 would give you a positive cos. What if I wanted to do a sine graph? Half of 35, 17.5, you're in the middle and going up. What if for some godforsaken reason I want to do a negative sine graph? Half of 35 this way, so 35 plus 17.5, that's going to be heading in the middle down. 52.5, I think. I'd go with this one. Okay. C. Calculate the height above the ground in 1 minute. Okay. Graphing calculator time. Clear whatever I got. Negative 21 cos 2 pi x over 70. I'm going to close the bracket off in front of the plus sign. 25. How about a plus sign? 25. I think that's how I type that, Maria. Yes? Oh, window. Yes, I cleared my screen, so you have to do it yourself instead of just copying from me. Did you get it typed in? You should be able to type it in. Like, if you can't type it in from that, we're in trouble. But what you need to do is stop looking up and just copying me verbatim. You need to start trying it and then calling me over and saying, what did I do wrong? So we'll pause. All right, we're back. What's our windows? What's x measuring? Time. In what? Seconds. Initially, I was going to say from 0 to 70 would be once around. Oh, how many seconds must I use to answer this question? 60. Will that cover 60? Oh, you know what? I'm good with that. For a minute there, I thought maybe I'd have to lengthen my window. If they'd said 2 minutes, Certainly, I would have had to lengthen my window, but they said 1 minute, 60 seconds. Good scale. 10. Yeah, no. Why min? I like to see the ground. Oh. What did we say? What's the highest we get? 46? What's a nice round number bigger than 46 that would be nice to graph? I'd go with 50. Scale. Oh, how about 10 again? And if I've done my job, hopefully Ferris wheel goes up, hits the peak in the middle, because I'm only graphing one period, and Ferris wheel goes down. Woohoo! Yes? If you didn't get that, now is your chance to fess up and I'll come help you. I'll make fun of you a little bit, but I'll come help you. We're all good? 1 minute, X value or Y value? T. But I'm going to type in X equals 1? No. What will I type in? X equals 60. 11.91, it says to 2 decimal places. H equals 11.91 meters. Did they ask me to find a Y value? They didn't bother. Okay. Sorry, did they ask me to find an X value? On your test, I'll have a part D where I say, when is it 20 meters high? Send a line across 20, find the first time. Okay? Okay. Then we turn the page. Some of these questions I think are a little bit overkill, some are just fine. Number 1 I would consider fair game, although really it was from the last unit. You would get the secant by itself. Can you see that you would actually end up with... You know what, Mr. Dueck, let's be really clever here. Let's go find where the heck you saved that, which was under downloads. Open with that, Mr. Dueck. Patience while I open this in another program. Loading, loading, loading. If I was doing this question here, I would minus 8 from both sides and divide by 4. I would get this. I would get secant x equals -2 over 1. What does secant go with? This is the same as flipping cos x flipping. Do I have a triangle with a 1 and a 2 in it? Yeah. Where's cosine negative? And I would get something like that. To be honest, I would find the reference angle. If it was pi by 3, I would cross out A and D. If it was pi by 6, I would cross out B and C. And then probably I would just find the first answer and quit. It's multiple choice. Why find the second one if I've eliminated all the wrong answers? It says determine the value of B if this has exactly 10 zeros. 10 answers. If there was nothing there, well, actually, I can't really say nothing. What number is there? It's invisible. But what's in front of an X just by itself? If there was a 1 there, how many answers do we usually get when we're solving a trig equation? 2, Castro, right? If there was a 2 there, when we did period changes, do you remember how many answers we ended up looking for very frequently? 4. Okay, if we have 10 answers, what must the coefficient have been? Yeah. Right? If there's, by the way, if there's a 3 there, you're looking for 6 answers. If there's a 4 there, you're looking for 8 answers. In fact, often as a multiple choice question, what they would ask is not solved. They would simply say, how many answers are there? And they would put that on the non-calculator section of the provincial, so you had to know this little trick, which I think you can derive in about 5 seconds. I don't have it blatantly memorized, but I can almost always spot the pattern by doing the couple of questions that I've seen. Number 3, which of the following represents all the restrictions? Shannon's looking at me. I should have cut and pasted that. Would you like me to do number 3? Restrictions, or are we okay? Yep, okay. If that means we end up doing all of them, I'm okay with that. What are the restrictions? Oh. First thing, rewrite everything in terms of sine and cos. What's tangent? So this is sine x over cos x all over sine x. By the way, do you notice when I have multi-level fractions, I always draw this line huge, long, so I can clearly tell which one it is? Stays organized. All right. What would make this fraction work out to 0? Sorry, what would make this fraction illegal? Cos can't be 0. Right? What about what would make you divide by 0 here? Number 4. I like number 4. I like number 4. I like number 4. Would you like me to do number 4? Oh. Okay. Ah! No, okay, I panicked. Now I'm ready to do this. That was my first thought. I went, what the heck? If it was cos squared plus sine squared, that would be really easy, because you know what cos squared plus sine squared is? 1. Is it cos squared plus sine squared? Wait a minute. It's cos squared minus sine squared. I have cos squared minus sine squared somewhere on my formula sheet, which you know I have in front of me coming to a tutorial because I'm a good student, so I can reference the identity stuff. What? You're telling me that this is cos, sorry, not 2. You're telling me that this is cos of 2 theta, where theta is that? You tell me it's that? Oh, I thought this was going to be tough. Oh, and what is 2 pi over 16 in lowest term? What's the correct answer? A, B, C, or D? 2 times pi over 16, right? 2 over 16, which is 1 over 8 in lowest term. This is an example of me giving you the right-hand side of one of those double angle identities and saying, make it fit on the left-hand side. I like that question. There's one, no, I think there's 2, where I give you either for the sum and difference identities or from the double angle identities, the right-hand side, and I say I go backwards and make it fit into the left-hand side. Multiple choice questions. Five I'm going to skip. 6 is good. What's the equivalent form of that? Here's a nice identity practice. This isn't a T-table identity. So I'm just going to keep working away on this until finally, at long last, hopefully, if all goes well, one of my multiple choice answers appears. Suggestions? I might, do me a favor, though. I noticed I have a secant squared and I have a tan squared. Is secant squared anything from the sheet? What is it? Tan squared sorry? What is it? Tan squared plus 1, and do I have a minus tan squared? I'm not going to rewrite everything in terms of sine and cos, not yet. Okay? Whenever there's squareds, I always glance along the top row first of my identity sheet. It's worth it, Emily, because apparently this is Dominique, what is tan squared? Take away tan squared. In fact, this simplifies to 1 minus cos squared. Oh, 2 lines. Had you not spotted that, had you rewritten everything in terms of sine and cos because you weren't planning your attack, 8 lines, I think, if I'm doing the math right in my head. It's doable. It's ugly. You would have written this as 1 over cos squared minus sine squared over cos squared minus cos squared over 1. You would have found a common denominator of cos squared. You ended up with a scary, yucky cos to the 4th, but it would have factored out with a GCF of cos squared. Yeah. Can I humbly suggest cleaner? Yeah, 7's overkill. 8's overkill. How would you solve question number 9 here? How can you just glance at number 9 and instantly tell how you're going to solve it? Graphing calculator, graph left side, graph right side. Oh, but what would your window be? Not 0 to 2 pi? No, 0 to pi. Okay. What am my vertical window? Well, a 4 there, I'm thinking an amplitude of at least 4. I'd probably go from -5 to +5, and then I might have to change it. I don't know. If all of the roots fit in there, great. Would I find all 3 roots? I probably wouldn't have to. I'd probably try and go with a process of elimination, saying, well, actually, these ones are all fairly close to each other, fairly close to each other, fairly close to each other. This is a better question than the one that I did earlier today, because you can't just eyeball this one. Okay. 10 is also graphing calculator. 11 is not. Wants you to find the general solution. How would you do this? Plus the root 3 over. I have a root 3 over 1. Do I have a triangle with a 1 and a root 3 in it? Yep. Oh, but what trig function? What's the period? Not 2 pi, not 2 pi, ugly cousin. It's going to be that one or that one. Depends whether the reference angle is pi by 3 or pi by 6. I'd have to draw it to find out. And they wanted the general solution, so they didn't give you between 0 and 2 pi. Okay. Number 12 is a bit of overkill. It's saying state the restrictions for this expression here. I'll show you how much I would expect you to do on this test. Oh, I thought the door was locked and you were going to open it. I would expect you to say, you know what? I would expect you to say this. I would expect you to say this. I would expect you to say this. Taking the square root of both sides, including in that the square root of 4 on the bottom is a 2, the square root of 3 on the top is a root 3, and did I square root both sides, plus or minus? But would I actually ask you to solve it then and find the angles and get the general solution like that? No. Not in this test. And I would consider this reasonably difficult. B, maybe even B plus level question. Nope. A would be something where there was a letter there algebraically and a letter there algebraically, and asking you, oh, if that's a Q and a J, what would it, oh, it'd be plus or minus the square root of Q over the square root of J, which that's the next. Most of the A-level questions are what we call literals, which means no numbers. Even though they're easier mathematically, they're scarier. Number 13 says, which equation could have the same solution as that or that? Nah, it's overkill. 14. How do I know 14 is not graphing calculator? But wait a minute, Mr. Dueck, it's got sine and it's got cosine. You said when it has sine and cosine, that's graphing calculator, but they somehow think we can do this exact values. Well, it doesn't quite have sine and cosine. It does have a cosine of x, but it has a sine of what? That's on my sheet! Go find it. Are you telling me that I can rewrite this as 2 sine x cos x plus cos x equals 0? What's the first thing that you always... Oh, there's a GCF now? Yes, there is. I disagree with your little no there. Yes, there is. Stop saying no. I'm saying yes. What's the GCF, Amanda? So... what are the roots? Whoa, alarm bell. Unit circle, probably. Have I got a triangle with a 1 and a 2 in it? Yeah, where is sine negative Castro? And that would give you those. Okay? That is totally fair game. How could you recognize it? Because the answers are exact values. Yeah? I don't... No. Behold the human unit circle. Where is the cosine work out to 0 when the x-coordinate is 0? There and there, yes? What two angles do you in your head showing no work? Oh, you picked up the phone again! Oh! God! Man! Pathetic. Oh. Oh, you gave him hope. You gave degrees hope again. Brett, what is it in radians, please? Pi by 2. By the way, how do I know it's in radians? Because of that. And because of, oh, yeah. Pi by 2 and 3 pi by 2, so that's wrong and that's wrong. You know what? I've done the sine of 1/2 so often, I know its reference angle is pi by 6. Ain't bad either. I know it. I've just done it so often. I guess the answer is D without actually solving all. Sabrina, I would on a test solve it if I had time, but the provincial exam used to only get 2 hours, not 3 hours, and so I was always teaching kids where can you cut corners, because if I could teach them to save maybe 12 minutes, that's actually a lot of time on a 2-hour exam for checking your answer. Now it's not so urgent. Okay. So there's an example of plugging in a known identity. Oh, if I gave you a cos 2 theta, you could use one of the double angle for cosine. There's 3 of them to pick from. Pick the one that has the same trig functions as are in the rest of your question. If your question has sines, pick the one that has sines in it. If your question has cosines, pick the one that has cosines in it. Probably wouldn't pick the one that has cosines and sines in it unless your other question had a negative cos squared that would cancel, or a positive sine squared that would cancel, or something. Sure, 15. Simplify. Okay. What is 1 minus sine squared? What's the square root of cos squared? Oh, the top works out to cos. Cool. What is cosecant squared minus 1? That's on there too? Oh, and what's the square root of cotangent squared? Are you saying this whole thing works out to... I forgot to copy this one again, Shannon, sorry. No, it's not. I told you I'd print this. I need to live up my side to my side of the bargain. Oh, now what would you do? So you're saying this is now going to be cos theta all over cos over sine? Yes, it is. And if you can see that, great. How do I divide by fraction? Flip it and multiply. I'll have a cos on the bottom, a cos on the bottom, a cos on the top. To be honest, what I taught myself, because I was a nerd, and I actually literally, I can remember in high school playing around with 3-level fractions and 4-level fractions to try and spot the pattern, and I learned in a big hurry, if these two were identical, that was your answer. I actually derived and memorized that little rule. I was actually really good at fractions. Anyways, that one looked scary. Turned out to fall apart. And that's part of my message, Maria, for identities. The ones that look scariest actually often aren't. That's over. We're going to get to some more. Simplify. Sure, let's do 17. By the way, how many of you are okay with word problems? Okay. How many of you are okay with quadratic trig equations? And let me ask this. How many of you are here, you want me to spend the bulk of the time doing identities? So that's what we're going to be winding up with for about a half hour. Okay. I'm getting this out of the way. But this is also multiple choice identities. All right. Simplify that. Okay, I would probably sigh too, but then I would jump in. Maria, any suggestions? Okay. What would you try, Brett? Why? And there's no squareds, and there's more than 2 trig functions. That's really, I better try that. Cotangent is, and if you haven't learned by now, do a big fraction bar. Be organized. Sine over cos plus 1. Okay? This is a 4-level fraction. Here is where my little compound fraction trick shines. Because here is what I would say. I'm going to multiply the top and the bottom by the same thing, by something over itself, by 1. What same thing? Dominique, what do I have there? What do I have there? What do I have there? My common denominator for the top and the bottom is going to be sine cos over sine cos, except I'm going to do that so that I can go boom, 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 boom. By the way, if you're doing the trig review, he probably won't put stuff over 1 when he shows the typing steps because it's irritating. Anyways, hey, when I do this, Maria, can you see I have a sign on the bottom? I have a sign on the top. They cancel, and I'm left with cos cos. What's another way to write cos cos? No, not on your sheet. Yeah, cos squared. All over. Maria, can you see here a cos would cancel? By the way, then you get your nerdy adrenaline rush. Have you seen it? Have you seen it? Have you seen it? Because I'll have a sine squared. Yes. Plus a what? Don't. Now what? Oh, bottom factor. Not sure where that's going to get me. I'm not sure where this is going to get me. Have I made a dumb math mistake? Let me double check. You'll get a sine squared. Cos will cancel. Secant is 1 over cos. A cos will cancel. And okay, I'm going to keep going. Rewrite cos squared. All over. Sine theta bracket. Sine theta plus 1. I have no idea where I'm going now. Let me see. Go ahead, ask. Where? On the top? Oh, are you brilliant, Shannon. Talk to me, Shannon. What can I replace that with? Why does that help? Nothing cancels yet. Except, go ahead. Okay. Ready? Can I cancel? Is this factored? Yes. Is this factored? No. So can I cancel? No. But wait a minute. How many terms? 2? Minus sign? Perfect square? Perfect square? This does factor. It's difference of squares, which we've hardly ever done, hardly ever had to use. This is a nasty one. But you know what? 1 minus sine squared is actually 1 minus sine, 1 plus sine. Did you hear the nerdy adrenaline rush right there? Huh? Wasn't that great? Oh, Shannon, are those the same thing? Can I cancel? Have I factored? So right now we're at this. 1 minus sine. And believe it or not, we're done. We are? I don't see it. Whoa. When you have a fraction, 5 over 2 plus x, you can't break this up into 5 over 2 plus 5 over x. You can't break up a denominator. However, x plus 3 over 5, when you have a binomial numerator, isn't that the same? Because you would start here, get a common denominator, and write it like that? Why are we done? Hey, what's sine over sine? What's 1 over sine? I would call that an A level. I would call that an A level. I would feel comfortable putting 1 on the multiple choice, not 5. Okay. Having said that, they would consider this fair game for a t-table identity, but probably they would give you a right-hand side that had some stuff to work with so that you could actually probably go halfway on each and meet in the middle somewhere without having to go all the way from one identity to get to this step. Well, I'll be honest. If they gave you that on the right-hand side, probably a lot of you would have written it like that and right away said, oh, there is a common denominator, written it like that, and been able to work your way and meet somewhere in the middle. T-table identities to me are easier. I'll throw this online and email it out. Return the books, by the way. I kind of like number 18, I kind of like number 18, I kind of like number 18. Which I presume means I'm going to do number 18. It's 1:45. I'm hoping to be done by 1:15. That's a complete lie. I was hoping to be done by 3:30 because I wanted to make the city hall before they close at 4 o'clock. But I'll do it Monday or Tuesday. You guys are worth it. Itzel, can you read this to me? Okay, take a deep breath. Try again. Here we go. Scene 1, Act 1, and action. Here's what I hear. Okay. What do I hear? At one point, I thought cos alpha, sine alpha, cos beta, but I know, are those the same thing? Then you know what? I see sine theta, cos theta. And there is on my formula sheet something that says sine theta, cos theta, not completely by itself, but that's going to give me the guide to where I'm looking. Alex, what is it? Okay. Is sine 2 theta 2 sine theta, cos theta? I can make that work into this somehow. In fact, I'm going to write down that identity. Oh. This sort of looks like that. Except, Steph, what do I have here? A 2. What do I have here? I'm going to ask you the same question, and I want you to give me the same answer. What do I have here? What do I have here? A 2 times 2. Oh. Don't I not? Can I not write this as 2 2 sine 10b cos. Right? There's the 4. I'm left-handed. This is harder than it looks. You guys okay with this? Now, what is 2 sine theta cos theta the same as? So, what's 2 sine 10b cos 10b the same as? This 2 is going to drop down, and this is going to be sine 2 times this is what I meant by I'm going to give you the right-hand side of one of those double angle identities and force you to work your way backwards. Dominique, does that go there? Does that go there? Then that's theta, so that also goes there. What's 2 times 10b? Right? And that dropped down.
Never known.
19's a little overkill. 20 I did last. 21, now we're on the written. Are you guys okay with a quadratic trig equation, or would you like me to do this quadratic trig equation here? First of all, how do I know it's a quadratic? Because it's got a squared. You want me to do this one or not? No? No, I wouldn't factor first. What do I have to do first before I do anything else? Okay, I plus the 1 over. This is one of the yuckier ones, no GCF, trinomial, leading coefficients. I'd be looking for 2 numbers that multiply to whatever, add to whatever. I'd group a group, break it down, and ideally then I'd end up with 2 factors, possibly 4 roots. Possibly one of your roots might be bigger than 1 or smaller than -1 and might have no solution. Oh, but if it's tangent, it can be bigger than 1 or smaller than -1 because tangent had a range of all reals, and I'm going to give you a tangent one on their test. I'll give you that hint right now as well. There's 2 quadratics on your test. One with sine or cos and one with tangent. And I'd be really blatant. I think in the tangent one, one of your factors ends up being like bigger than 1 or smaller than 1. You're going to be tempted to cross it out. Don't. Yeah. No. Yeah. Can't be 2. Sine has to be between -1 and +1 as well. But tangent, remember the graph did that. Oh, in fact, I could give you tan x equals 1,000,000. And technically you could solve it. I don't think I would, but there'd be an answer. Okay. All right. That's a pretty easy proof because I think you FOIL it out and a bunch of stuff cancels. This one looks a bit more interesting. Identities, 23. Again, please make sure you're not writing in my booklets. Which side am I going to spend most of my time on, Maria? The left side. Although I think the right side is clean enough, I'll actually just start there, tidy it up, and then go leave it alone. What are my strategies going to be here? Several. Double angle substitution, I'm going to replace that with 2 sine x cos x. I'm going to replace this with one of the 3 cos double angles. I'm not sure which one, but I think I'm rewriting everything in terms of sine and cos. What's cotangent? What's 1/2 cotangent? Well, the 1 is on top and the 2 is on the... That's the right side. Yes, there's a 1 on top. Do I need to write the 1? Forget it. All right. Left side. This is and I apologize, this is going to sound like I'm insulting you. I don't know a better way to describe it. This is what I call a no-brainer substitution, in that if I'm doing an identity and there's a sign 2x, there's only one thing it can be, and it's on my sheet. I just read it out. What is the sign of 2x? Except I'll put x's. And I won't take marks off if you put thetas, but I'll say it. Oh, and I'm going to, Dominique, drop this plus sign squared down, because that is in terms of sine and cos. This is not, well, it says cos, but it's a 2x. I want to get rid of that. Now, cosine 2x, I got 3 options. Find them on your sheet. One of them would be a way smarter option. Tell me which one you think would be the way smarter substitution. Amanda, you're right. Why would cos squared minus sine squared be clever? Because if I put a minus sine squared right there, what do I have right there? Plus 2. The 1 minus sine squared, the 1 minus 2 sine squared would be the next most clever. The dumbest would be 2 cos squared minus 1. You'd still get there. They all work. One gets you there in 2 lines, the other gets you there in 4 and 5, if my math is correct. I'm going to choose this one. And whenever I substitute the double angles, because they're binomials, I always plug in put them in brackets just to be safe. In this case, the brackets don't make a difference, but sometimes they do. Yes? Prove it. Yeah.
If you're putting tan down and you were trying to put it into sine over cos, that means we wouldn't. Oh, I kind of. Okay, so how we did this equation, you pretty much how you. Never mind.
Well, first of all, you keep saying equations. These are not equations, these are identities, and maybe you're getting a strategy for equation solving, or we're trying to get next myself, mixed up with a strategy from we're trying to make a left side look like a right side as a proof. So keep thinking. If you find a better way to phrase it, or you find an example like it, or one comes up here, shout out. Amanda, brilliant. Because now I get this. Cos squared on the top. Can I cancel? Is this factored? Well, the only way it's not factored are if there are plus signs. Is there a plus sign somewhere on the top? That's factored. Is there a plus sign here? Then they're all being multiplied, and it doesn't factor, actually mean multiply, like the word factor. What are the factors of a number? It's what multiplies the number. These are both factored. So here's my question. Can I cancel? Yeah, it is factored. How many coses on top, Itzel? How many on the bottom? Yeah. Oh, by the way, could you also have picked up on that hint by looking here? Look. Oh, yeah, probably that's going to be it. So although that one started out looking really godforsaken ugly, 2 lines. Mr. Dueck, yeah. What if I plugged in, because the other common one was the minus 2 sine squared? Watch, Dominique. What if you went 1 minus 2 sine squared, and then there was the plus sine squared, all right. Or, and it was over what's negative 2 sine squared plus 1 sine squared? 1 minus, the 1 still stays, yes. Dominique, what is 1 minus sine squared? Are you there? Yeah. The 2 cos squared would also work, but be yuckier. That's why I said for the cosine double identity, pause, plan, think, do a couple lines in your head, then go. And if you're not sure, my fallback is usually the cos squared minus sine squared because it's the most flexible. Uh, 24. Yep. And please remember, I sent out 2 other videos already, which I think were year-end ones that might have been a bit better, but I can't remember. Because it's been a year and 2 years since I did them. All right. Spence, what am I going to do here? Yeah, I think this one's crying out to be cos over sine, cos over sine. Oops, Vlad, I just wrote a fraction. Put that over 1 as well. Put that over 1. Put that over 1. This is a complex fraction on the left side. My decision now is made for me. When I have a 4-level fraction with multiple fractions and multiple fractions, I'm telling you, your best move is to multiply the top and the bottom by the common denominator, which in this case, Emily, is what? I'm going to go times sine, times sine. Is sine over sine 1? So this is legal, right? I'm not changing the question, but I'm also going to add that now. On the top, I'll get sine cos plus cos all over. By the way, is there a GCF on the top? Yeah, what? What's on the top over here? Hey, I'm on the right track. Probably. On the bottom, here's my Mr. Dueck's little shortcut, Brett. Will anything cancel at all on the bottom? Then do yourself a favor. Just leave it as sine theta plus 1 times sine theta. Leave it multiplied out. You could multiply, sorry, leave it factored. You could multiply it out, but you know what you're going to end up doing on your next line? Factoring it. You know why? Can I cancel? No. Why? Let's factor the top out. Cos. You see now why I left the bottom in brackets? See if we can do a couple of nasties. I'm not going to give you one like that. Oh! We've run out of stuff on the test. That's pretty much what you're going to see. I think if you work through the review... Yes, Brett. Okay, let me find said copies. From the one that I just recently handed out, the Big Identities one and the Trig reviews? Okay. Hold on. Yep. Okay. Did you look at my online answer key? Good. This one was surprisingly tough because there wasn't much to work with. On the right side, I rewrote everything in terms of sine and cosine, and I got a sine to the 4th, which terrified me, but I said, I don't know what else to do. On the left side, I said, okay, I wrote it like that. How many fractions do I have here? 1. How many did I have here in red? Said, let's find a common denominator. The common denominator is going to be what? Cos squared. That just dropped down. Here I multiplied the top and bottom by cos squared. So far, so good? Nope. Okay, I need to do this one then. I went sine squared over cos squared times sine squared over 1. I said, okay, this works out to sine to the 4th over cos squared. And I got nervous because I don't like sine to the 4th, but I can't think of anything else to do on the right-hand side there. I'll live with it for now. Left side, I said this is sine squared over cos squared minus sine squared over 1. How many fractions? No, over here. How many fractions? How many fractions? Let's try writing it as a 1 fraction. The common denominator would be cos squared, yes? Right? This is already over cos squared. It drops down like a domino. Minus drops down. What would I multiply a 1 by to change it into a cos squared? Same to the top. And I got I said, oh, I'll pull out a GCF because I don't know what the heck else to try here. But I said there is a GCF, so I was going to try something. I factored out a sine squared, and I got a 1 minus cos squared, and I went, ah. First of all, I was pretty happy with the denominator, yes? Hey, what's 1 minus cos squared? I have a sine squared, sine squared. That's just like what I... Ah, there's my sine to the 4th popping out here, isn't there? This is going to be sine squared. Is that okay? That was a much tougher one than I expected, because it also said 3 marks, which made me lower my guard. But these are from the older exams when the marking scheme was different. There was a longer written section, so they weren't worth as much. Next. And also next for any of you, Itzel. From which one? Thank you. Give me 1 second. Let me go hunting for it. Where the heck did I put that? Come on, computer. Question 2, like here. Question 2, like... Oh, okay, this isn't quite the review that I gave you guys. Let me go find the actual copy, which is going to be under Notes for Students, Block A. Here? What number? 2C? Okay. Totally fair game. In fact, I may like that question. What kind of an equation is this? How do you know? How do I solve the quadratic? Make it equal to 0. It already is. Then what do I do? Factor. What's the first thing that I always... Oh, there is one. This factors into sine x bracket 2 sine x plus 1 equals 0. That's very similar to this from Math 11. What were your roots here? No, not 1 over 2. So you're definitely going to have a... What was your root there? There was one. Yeah, 0. Right? So you're also going to have a... Whoop! Alarm bell, unit circle, wherever y is 0, that's when sine is going to be 0. So it's going to be, I think, 0 and pi. I think if I'm doing the math in my head. And then this is going to be 7 pi by 6 and 11 pi by 6, I think. But I'm doing an awful lot of math in my head there. I could be wrong. Don't forget that. I meant to make that easier, not tougher. Okay? I think you might like that question. Or I might. Brett, your turn. Unless anybody else raise your hand. But yeah. Oh, Amanda, go ahead. Number 3. Did you look at my online answer key? You okay on the right side? Okay. So I rewrote, as soon as that became a fraction, I went back and put them all over 1. Tangent is sine over cos. Sine times 1 over cos. I rewrote everything in terms of sine and cos. You okay with that? Tidied it up. I said, okay, it's cos over 1 plus, what's sine? Over cos. All over sine times 1 divided, oh, that works out to sine over cos. Complex fraction, what's my little mini common denominator? So multiply by cos over 1 over 1. Ooh, here I get a cos squared, yes. Here a cos cancels, by the way, what is cos squared plus sine squared? Oh, here the cos cancels, I get a sine. Yep. Doing what? It's to go from 4 level fraction to 2 level fraction every time in one step. 4 level fraction to 2 level fraction, and that'll work every time in one step. It'll clear out every single mini denominator and leave you with one set of stuff on the top, one set of stuff on the bottom, but no bottom on the top or top on the bottom or anything like that. That's what it's for. Oh, and once you have it looking like that, then almost always you can factor and cancel. Vlad.
Main class, can you say for restrictions, the cost is allowed to be equal to 0?
Sure thing.
So number 3 and this will be good. That's kind of short sum without all restrictions.
Boy, number 3?
Yeah.
This one here?
Yeah, why is cosine a restriction?
Because cosine's not on the top. Cosine's in the bottom on the top. Right? I have that written down here. Let's go find it. Tangent, that's a fraction. Where's cosine? You tell me cosine's on the top? This is why I always draw that big line. Cosine's in the bottom of a fraction. It's not in the top of a fraction, it's in the bottom. Now, that fraction is located above another denominator, but clearly cosine is a denominator. Does that make sense? Awesome. Next. The first 2a, not this one. This one? Yep. All reals. What's the vertical displacement? What's the vertical displacement? 5. What's the amplitude? So from 5, it's going 2 up, 7, 2 down, 3. The range is between 3 and 7. Right? You're overcomplicating that one, I think, because that... Sorry, but I'd call that like a C plus question. Sorry, but... Right? Range to me isn't the tough one for sine and cos. It's vertical displacement plus the amplitude minus the amplitude, and we're done. You gotta keep them straight, but oh, for Pete's sakes, memorize a little bit. You do way less memorization here than in biology or something like that, so I figure it's fair game. Any others? All of them. What I mean is, there are certain identities that you haven't seen yet. Those will be on your test, but if you want to get a feel, there's a reason I gave you a bunch. Remember that speech I gave about treading water and not drowning? There's a science to it, there's an art to it, and the only way that I know to get to the science and the art is to practice a bunch of them. It's a... Of the identities review? Yep, later. This one here? Sure. Yep. That's a great question. Let me go find out. Let me copy this first. First of all, there is no sine 3x. There is a sine cubed x. Right? Did he maybe GCF, factor out a sine, which would make that a sine squared? Do you want me to do it anyways? Then it falls apart? Let me go see. B. Yeah, that's a cube became a square. Factored it out. Oh, and what is cos squared plus sine squared? Yeah, it really falls apart because now it becomes sine x times 1, which is just sine x. And 1 divided by, it's 1 over, oh, how do I divide by a fraction? Yeah, that one falls apart if you see that GCF, which is the first thing that we always. Yeah, there's methods to almost all my stupid stuff. There's reasons for all my stupid stuff. Even the shouting. Vlad! Sure can. Did you look at my online answer key? You guys know it's there, and there's several copies in class, just saying. Okay. This one looks yucky. Anything with a binomial denominator, 2 terms in the bottom, creeps me out. That's a lot of work usually. So I'm prepared to have to plug away at this. Suggestions, Vlad, my friend. Maybe. How many different trig functions appear here? See, that's right along where maybe I want to try doing stuff leaving the cotangent and the cosecant in. So I'm going to try 2 ways. First, I'm going to see if I can leave the cosecant and the secant, and I'm going to skip your step. And then I'm going to say, can I factor? No. Are there any squareds? No. As a last resort, do I have a binomial denominator with no squareds? Yeah. And what is the conjugate of this, by the way? Is that what I have on the top over here? That suggests to me that I should try that. I'm going to go cosecant plus 1, cosecant plus 1. You okay with that so far? On the top, I could multiply it out. I'm just going to leave it factored for 1 line on the off chance that maybe stuff will cancel. So I'm going to leave the top as cotangent cosecant theta plus 1. But in the bottom here, I'm going to get cosecant squared. Then I'll get a plus cosecant and a minus cosecant. Yes? And a minus 1. Ooh! What is cosecant squared minus 1? Can I factor? Sorry, can I cancel? Is it factored? How many cotangents on top? How many on the bottom? How many left and where? 1, and I'm done. I just write the final answer. So if I did not go in terms of sine and cos, 1, 2, 3, 4 lines would be to get my final answer. What if you wrote it in terms of sine and cos? I might have done that the very first time if I was doing this absent-mindedly. What number was that? Nope, I spotted that this time. I think you'd get a bunch of complex fractions. You would, on both sides, cancel the complex fractions using that trick that I showed you. And then you would still end up doing the conjugate afterwards, because I think you would end up with a binomial denominator with no squareds.
Cos theta over 1 minus sine theta.
Yes. And then 1 plus sine theta over cos theta. So then you would say on your line, well, oh, hey, what is the conjugate of the one with the binomial denominator? Is that what I have on the top of the right-hand side? Hey, there's another hint. Right? I'm going to argue mine's more elegant. Next. Unfortunately, folks, for this unit, specifically for the identities and the applications, There's no substitute for doing a bunch of them, especially the identities. I can give you hints and guidance, but you got to take the plunge, which is why you'll notice I'm demanding the identities review. I learned the hard way a few years ago. Photocopying that doesn't work unless you make the kids do it. You all know where my online answer key for that is, so make sure you can utilize that. There are other ways to get there as well. I have a different online answer key made by a different teacher, and she uses a slightly different order of hints than I do. I like to think mine is the cleanest. Now, any other questions? If not, I'll hit save and I'll then see who wants printouts. Okay. Yeah, I can get you all that. Give me a second here.